Good morning everyone, we are group 6 and now we will do experiment number 6, which is the reduction of sample size by quartering method, the determination of specific gravity, water absorption and moisture content and densities of coarse aggregate. For the objective, the purpose of the experiment is to decrease the sample size of coarse aggregate by applying the quartering method. Next is to examine the coarse aggregate physical properties to see whether they are suitable for concrete.
For the materials that equipment, we have the coarse aggregate, the rectangular container, absorbent cloth, mixing plate, flat edge shovel, drying oven, digital weighing balance, and sieve number 4.
You will now weigh the rectangular containers.
Collect the samples on a level, hard, and neat surface. Mix the samples repeatedly with the shovel. Flatten the shape of the pile into a flat and even level. Divide the samples into equal quarters using the shovel and proceed to remove a pair of diagonally opposite quarters.
Now we are going to sieve the coarse aggregates.
Place the samples into 3 containers and wash the samples to remove dust. Measure and find the volume of the containers. The 3 samples are to be submerged in water at room temperature for a period of 15 to 19 hours. After 15 to 19 hours, place the sample in a container and weigh it in water. Spread the wet samples on a dry towel to absorb the water from the samples. Then weigh the samples. Place the sample in the drying oven for 24 hours. After 24 hours, remove the samples and let them sit at room temperature for 1 to 3 hours. After 1 to 3 hours, record the weight of the oven-dried condition of the samples. The experiment aimed to determine the specific gravity, water absorption, and moisture content and densities of coarse aggregates while using the quartering method to reduce the sample size. These properties influence strength, workability, and durability of concrete. The specific gravity values indicated relatively low aggregate density, suggesting high porosity. The water absorption ranged from 1.56 to 5.56%, which may require adjustments in concrete mix design. Density analysis further confirmed that aggregates have lower densities than standard aggregates. The findings suggest that the aggregates may not be suitable for high-strength concrete due to porosity and water absorption. Additional tests on mechanical properties are recommended to assess overall performance.